Hi there guys, and welcome back to the shop for episode 9 on the Neon Sign Transformer series. Today we're going to talk a little bit about grounding, because this is a very simple thing that gets unimaginably complex the more you dig into it. So by all means, spend some time on Wikipedia, get in there, really dig down on learning about grounding. The first thing I want you to do is learn the difference between a grounding conductor and a grounded conductor. They're easy to confuse and they mean two very different things. You're gonna go down the path on some theory. I'm gonna cover the practical side of things here, but this is a good time for you to start learning some basics of electrical theory as you get in there. So get into grounded versus grounding. Start there. There's a lot to learn. So your basic NST and the test cable both have 3 terminals. And I'm dealing with North American, European, you guys are different. I trust you to figure it out. But for the standard American system, you've got your black is your hot, your white is your neutral, and your green is your ground. Because white is the color of neutrality, black is the color that you turn when you touch that wire because it's hot, and green is the color of the grass and the ground outside. You should see the mnemonic they use for the British system where they have brown as the hot conductor. I'll let you figure that one out. So normally when we're using this, electricity comes in on the hot from the power company through the control circuitry that you have, your switches and fuses and stuff, through your circuit breaker, all the way back from the power company, all the way out to your hot terminal right here. It goes through the center coil in the transformer. It does its little magic pixie stuff and it goes back to the power company on the neutral. Okay, you don't actually buy electricity, you just kind of rent it. Power company takes back just as much as they give out. That's supposed to work that way. Normally, when everything's going right, there's no electricity going out on the ground. There's nothing happening there. It's just a reference, but it's an important reference because it tells us what 0 is. And we talked earlier about electricity being a number line with the 0 to 6,000 volts, and then you get 12. Well, you need to know where the hell 0 is. That's your ground reference, because weird things happen if you don't have a 0, and you've experienced this. You have experienced what happens if you don't have a ground reference. Especially if you live where the air hurts your face, if you've ever walked across a carpet and touched a doorknob or a light switch and gotten that zap of static, let's take a minute and think about what actually happened to you. What you did was raise the electrical potential of your body. You charged your body up to 20,000 volts, maybe 50. It's really easy to do that with static. It's nothing to scuff your feet on a carpet and build up 20,000 volts on your fingertips. And then when you touch that grounded outlet or that grounded light switch, you discharged all that energy to ground in a big rush. But for a moment, you were charged up to 50,000 volts, but you didn't know it because in reference to you were at 0. In reference to ground, you were charged up to 20,000 volts or whatever. But as long as the reference from you to you is 0, you're fine. As long as you don't have a separate ground reference and you are your own reference, doesn't matter. Voltage is the measurement of a difference in potential between two things. Ground is our standard reference for one side of that voltage potential. So to that end, it's very important that when you plug your neon sign transformer in, you better have 3 wires on your thing, you better have 3 prongs on the plug, and you better have 3 holes to stick it in. This is what your outlets should look like, and if they don't, you've got problems. Maybe. Here's why. Old outlets, and you got to go back decades for this to be a problem. Old outlets don't have the mouth. They just have 2 holes like that. Those 2 holes they may or may not be polarized, but at that point, when you just have 2, that's an ungrounded receptacle, okay? If the holes are 2 different sizes, then you have a polarized receptacle. If the holes are both the same size, then you have an unpolarized receptacle. And those are really, really, really dangerous. So what you want, if you're gonna be playing with high voltage and learning about this stuff and experimenting with it, you gotta start somewhere, you gotta have this. Yes, I know you can get the adapters. You can get these things, okay? These little adapter widgy bits. These are horrible, you shouldn't use them, and they're a great way to get somebody either really hurt or potentially burn your house down. And the reason why, and you can, don't take my word for this, man. Check this out for yourself. Try this at home, okay? This does not have a connection to neutral. It doesn't create a connection that doesn't exist. I've tested them. I can do it right here. We'll grab a meter, we'll fire this up. I will show you, because we can do science. All right, I've got a meter right here, and if I touch them together, it beeps, and that's measuring ohms. So this gives us a continuity check. If there's electricity flowing through, it beeps, right? Now, if I take this device and I put one terminal in there and I touch it on the ground thing on the back, it beeps, okay? I'm measuring from ground to the little lug. If I measure from ground to the hot side, nothing. If I measure from ground to the neutral, nothing, and that's the problem. Because this doesn't connect ground to neutral. For some things, if you're cheating, and you shouldn't do this, but if you're cheating, if you connect ground to neutral on here, at least you've got some kind of safer, it's not safe, it's really dangerous actually, but it's safer than what you had. So if you take that outlet and you plug this in, look, there's one installed in a real outlet, okay? If you have this installed, the way this works is it connects ground to the screw, right? And the screw connects on the back. You've got, these are your neutral side, because they're white, they connect to the neutral, the big hole. These are your hot side, they're brass, they connect to the little hole, right? But what connects to that screw? Well, that's easy. That connects to the frame of the outlet, which connects to chassis ground, the green wire in your house. No problem. Everything's fine. That's great, but if you're using this, you don't have a ground hole, which means you don't have the green wire. And if you don't have the green wire, what the hell exactly is that connecting to? Nothing. Nothing. It lets you plug this in to a thing, but this pin isn't connected anywhere. It's giving you a false sense of security, and it's making you feel better about yourself, but it isn't actually doing anything. So that's what you want, a proper 3-prong outlet. And if you're gonna be messing with this stuff, it's a really good idea to get one of those. This little toy is an outlet tester. It's a fabulous little tool made by Klein. This is the fancy one with the Gfci testing button. And this is the Romeo Tango 210. And all this does is it has 3 little lights that come on when you plug this in an outlet. And as long as, and you can see there's a little handy decoder chart, as long as the 2 orange lights, center and right, come on and the red doesn't, you're fine. Here is entirely how to use this tool. Ta-da! I'm using my tool, and you can see my outlet is wired correctly because I have the 2 right lights on and not the left. That's it. But what this does is lets you know that you don't have an open ground, an open neutral, open hot, whatever, and that it's wired correctly. The big important one on here is that you don't have an open neutral and that you don't have hot neutral reversed, because people screw things up all the time. Just because the outlet in your house has worked fine for years doesn't mean it isn't wired correctly. So you check these things, and these are easy to get and they're cheap. They sell them at all the big box stores. I've got like 3 of the damn things knocking around. So they're easy, and it's one of the cool tools that even if you're not an electrical person, this is totally safe to use because you're just plugging the thing in and reading lights. You can handle that. So we've covered the importance of grounds. We've covered how to do a thing. The last thing that I want to leave you with is the end of the line of grounding. This is important to know. When you're using this with like a Tesla coil or something like that, this is the end of the line of your mains ground, because this is where you jump to high voltage and go out to the Tesla coil tank circuit, and you've got all kinds of different things, frequently dangerous things happening out there. The chassis ground on here connects to the plug. That's the highest voltage place it's going to see is this transformer. The chassis ground goes to the neon sign transformer, the control system, that side of things. We're going to establish a totally separate RF ground. And that's what you're going to use for the base of the secondary, the center point of your safety gaps, all that stuff. Anything out at the Tesla coil goes to a totally separate ground. The only wires that go between this and the Tesla coil are the high voltage feeds. That's it. You don't tie that into ground because it gets dangerous. You don't want to be dumping big, nasty, noisy stuff into your house's electrical system. That's just a bad time. But that covers all the basics there are to know about the fundamentals, the really early basic stages of grounding your neon sign transformer. Okay, cool. So with that, I want to thank you for hanging out, for learning a few things, for enjoying the shop, for getting a little freaked out by Clamperella. You guys have fun. I'm Chris Bowden, and as always, I'll see you next time.